I lost my connection for a minute, so I have to restart a new video. So in general, when we look at different type of cache, so the first one was called direct map cache. The second type is the set associative, and the last one is fully associative cache. So the fully associative cache does not have any fixed mapping principle. Does not have any fixed mapping principle. So if you still remember, for direct map cache, suppose your block number is 0, then you have to put, so the block address is 0, then you have to put it into the first location of the cache. Suppose it is the first location of your memory, then you have to put it in, you have to map it to the first location of your cache. So suppose you are mapping the first address in your memory, then you do not have to map it to a particular block, but you have to map it to the first set inside of the set associative cache. For a set associative cache, suppose I'm trying to map the memory location 0, then I do not need to map it. So I have to map it to the first set. I have to map it to the first set, but I will have 2 different locations to select. I will have 2 different units, 2 different blocks. So I could either put it in the first block or put it in the second block. It doesn't matter, but I do have a little bit flexibility. I do have a little bit flexibility, right? However, for a set associative cache, there's no requirement. There's no requirement of your mapping. Suppose you would like to map the memory address 0, then you can pick any of the block inside of your cache. You can pick any of the block inside of the cache. So that's why we call it one entire set. That's why we call it one entire set. So in the direct map cache, so one set is only one block. One set is only one block, so you have no choice. You could only put in a fixed location. But for a set associative cache, you could have multiple blocks. You could have multiple blocks inside of one set, So instead, actually you have to map to a particular set. However, you could determine which block you want to use, For a fully associative cache, so you only have one single set. That means one set includes all your blocks. So you can pick any random block you want. And put the data in it. So I was talking about an example in the previous video. Assume you are trying to go to the memory and borrow some books. So you have a small cart. So for example, your kids like the animal book, the math book, the science book, 3 different types of books. So you may have many books for math. You may have many books for science topics. You may have many books for animal topics. So you have like a lot of different books, right? However, the animal book have to map to the first drawer inside. So you have like a few different drawers inside of your big cart. So you have a cart and you have a few different drawers in the cart. And suppose for any animal book, you have to put it in the first drawer. And then for any math book, you have to put in the second drawer. For any science book, you have to put it in the third drawer. Try to be a little bit organized, right? So then this is, how your drawer is designed. For a direct map cache, then you only have one book location inside one drawer. So each drawer could only hold one book. For a set associative cache, so if your cart is designed like a set associative cache, so you will have a couple different locations inside of each drawer. So that means you could put 2 books for science topic. You could put 2 books for math topic. You can have 2 books for animal topic, but you can only have 4 different types of books, right? For a direct map cache, you can have 8 different topics. So for a fully associative cache, then it doesn't really care. So you can have any book you want, and then you just randomly pick one location and put the book in it. That's it. So there's no mapping requirement. So So it's kind of like that kind of parent go to the library to borrow a book, and they actually don't think anything about being organized. So they just want to, you know, I'm only able to hold 8 books. So that's all the requirement I have. All the requirement I have is, you know, my capacity of the cart, of the cache. So the cache is only able to hold 8 books. So I will pick one book and put it in the cache, pick a second book, third book, until my cache is full. And then later on, so what's the difference between them? So well, right now, you know the mapping are different, but why they're different in, if you're thinking about to use the cache, then you will know, you know, what's the real difference here. So suppose if I would like to find the book, take a book from my cart, So like my child, you know, my daughter is waiting for me outside of the library, and she want to read a book right now. And then I will take my card to my daughter, and my daughter, suppose she is the CPU, so she would like to read a book, and she will check my card, which is the cache, right? Suppose the card is a direct mapped cache, and then you could have like 8 different topics, and then she knows where she should check. If she want to find an animal book, she will only look at the first drawer, right? But you know, as you only have one book in it, so you have like a relatively lower possibility to have that book. You know, she may say, well, I do not like this book. If you do not like this book, then there's no way for you to have the animal book, because you only have one animal book in it. So for the set associative cache, you have 2 different animal books in it. You know, you have 4 different drawers, but if you're looking for an animal book, then you could have like a, you know, 2 different options. And for the fully associative cache, then if I'm looking for an animal book, I really don't know if you have it or not in the cart. There's no way for me to know it, because there's no fixed mapping policy. So what I have to do is, my daughter have to do is, she will need to search all the drawers, all the different locations. So we need to search. There's only one drawer, but there are 8 different locations in that drawer. So she will have to search all the 8 different locations to see if she could find the animal book she wants, right? So the biggest difference here is, for a fully associative cache, there's no fixed mapping. There's no fixed mapping policy. For a direct map cache, so your mapping policy is 100% strict. So for a certain thing, then you have to map to a certain location. For a set associative cache, then you have a little bit flexibility. It's kind of like in the between of them, right? So have a little bit flexibility to select one location inside of a set. So if we have the fully associative cache, and then when we're trying to find something, of course we have a lot of flexibility. However, if you would like to find something, then you have to search all the different locations. And suppose your cache is super huge, it is almost impossible. Right? So of course you really like this idea. Well, it doesn't bother me a lot to do the mapping, and there's no work required for the mapping. I can just you know, put anything in an empty location. As long as my cache is still have some space open, then I would put more things in it. And however, this is almost impossible to implement, because you do not want to search all the locations when you try to read something from the cache. You do not want to search all the locations. It will be super expensive, okay? So, and let's first look at set associative cache, and we will start with an example. So the problem for the direct map cache. So why people come out to the idea of set associative cache? Because there's a huge problem, a big problem for the direct map cache. So what is the big problem for the direct map cache? So suppose this is the program we're trying to implement. And then all the program trying to do is to load from a memory location address 4 and load from memory location address 24. So I will keep loop this, repeat this again. So you could repeat it for 5 times, you could repeat it for many times. Suppose all we are trying to do is implement this assembly code. So we're trying to load from memory address 4 and then 24, 4 and 24, 4 and 24, 4 and 24. Keep doing this. So suppose we are doing using a direct map cache, and this cache has 8 different locations. And remember, it is a direct map cache, so each location is called one set, and each set has only one block, as this is a direct map cache. So each set has only one block, right? So the block is set is block. And then for the memory address number 4, so 0x4 here is a 32-bit address. Remember, it is a MAPS assembly code. So each address is a 32-bit address. So you have a bunch of 0, and the last 4 bits will be 0100. 0100. And I will add a few more bits here. So when I look at the 32-bit address here, this is a 32-bit long address. So the lower 2 bits, I don't need to worry because they are always 0. They are always 0. And then because I'm using a 8 sites direct map cache, 8 sites direct map cache. So I will need 3 bits. I will need 3 bits to represent the set index. I will need to use 3 bits to represent the set index. I will need to use 3 bits to represent the set index. So this is this, right? 3 bits to represent the set index. So 001 means it will map to set 1. It will map to set 1. So the address 4 will map to set 1. The address 4 will map to set 1. And how about the address 24? How about the address 24? So again, you have a lot of 0. And then the last 4 bits is also 4. So you have 0100 because this is number 4. And number 2 will be 0010, right? So this is your hex translation to binary, And then again, the lower 2 bits, I don't need to worry because they're always 0. And I would like to separate those 3 bits out because I will need 3 bits to indicate the set index. 3 bits have to be used as a set index. 3 bits have to be used as a set index. So the 001 here means, again, it will map to the set index set 1. Again, it will map to set 1. Again, it will map to set 1. So both the address 4 and the address 24, they are mapping to the same set, the same set. So what happened here is if the program is executed, then the first address the CPU see is 4. So what does the CPU do? It will put the data of address 4 into the set 1, right? It will put the data of address 4 into set 1. And later on, it will see the address 24. It will see the address 24. So what does the CPU do? It will have to put the 24 into set 1 because, each time, because they map to the same location, And what's the usage of the cache? So when you see a piece of data, then you wish this piece of data will be used again. So you first put it in the cache, and then you hope later on you will have it in the cache, and you could save some time. Instead of reaching out to the memory, then you could just load it from the cache. So when I see the address 4, data from address 4, I put it in a cache. And then unfortunately, if you only load from address 4, then this will be perfect. So the first time you have a miss, and later on you will have hit because it is there from after the first time. However, because I'm using both the address 4 and address 24. So first of all, I will load the data from address 4 and put it in set 1, and later on I have to replace the data with address 24, with the data from address 24, with the data from address 24, because they map to the same location. And then the next time for the second loop, so what we are doing is first put the address 4 into this location, and you have to update it, put the data from address 24, and you have to update, because the third load for your second time of the loop, you will use 4 again, and you find, oh, 4 is, the address 4 data is not in the cache. So you have to kick out the 24 and put the address 4 data in it again. So you have to kick out the 24 address 24 and put the data from address 4 again. And then you will find, oh, I have to use the data from 24. So then that time you have to kick out the data from 4 and put the data from 24. So those two different addresses, they are competing with each other. They're competing with each other because they share the same set index. So the same set index. So you never have a hit. You always have miss. You will keep have miss, because you keep replacing the previous data with the current one, and you always want to use the previous one. So this is the worst case for the direct map cache, and unfortunately, this will happen a lot of the time. So the problem for the direct map cache is, a lot of the time you do have different address, they share the same set index. So you have to replace again, and you never have a hit. You always have miss. So the real problem for the direct map cache, because multiple address inside of the memory, they share the same location, share the same set index. They share the same set index inside of the cache. So how can we avoid this, or how can we improve this problem? So for like the previous example, if it's not the address 4 and 24, so you can even check 8, 4, 6, 4. So any even number and 4. So all those address, they will map to the same set address. They will map to the same set index. So to solve this problem, then of course, the solution is today's topic, n-way set associative cache. So instead of using the direct map cache, we could use n-way set associative cache. So what is n-way set associative cache? Suppose we're still focusing on simple example again. So suppose we have 8 different, the capacity of the cache is 8 words. So you have 8 different locations inside of the cache, but instead of organizing them in 8 different drawers, so you change this to be 2 columns, and each column you have 4 different rows. So instead of having 8 different rows, 8 different sets, and I will have only 4 sets. But each set, I have 2 columns. And each column is called way 0, way 1. Each column has a unique way index. So you have way 0, way 1, 2 ways for each column. And of course, if you originally have 8 sides, right now you only have 4 sides because you have 2 different columns. And then how we store